Welcome to this short lecture on stream restoration. I would like to point out and thank my daughter Michaela, who did a lot of the background research for this particular lecture. As we are all doing kind of our stay-at-home learning, she decided to go ahead and take on this topic, and most of the imagery that you're going to see generated throughout this lecture is the result of her efforts. The following slides are going to walk you through the process of stream restoration, but really this is the overall summary. And again, I'm not a complete expert on restoration ecology when it comes to stream management. I've been around this process. We'll talk about some of the limitations of kind of taking a broad generalized approach to this, but that's not the intent overall of this particular lecture. This is to provide you with a basic understanding, right? Preliminary understanding of how the process of stream restoration occurs, and then how can you use that to inform the work that you're doing within your capstone project development. One of the most important reasons we won't be able to cover the entire topic is that stream restoration is a broad practice, lots and lots of different applications. One of the things just to keep in mind is that the general purpose, why are you restoring the streams, right? There's a number of different reasons that they fall into habitat enhancement, water quality improvement, improving the aesthetics. I mean, again, it can be a multi-goal project, but depending on which goals are being prioritized, it's going to change how you approach the specifics of laying out kind of future revisions to that stream, to the channel, what species you're managing for. So if you're managing brook trout, there's specific requirements related to how much gravel needs to be on the bottom and not be exposed to heavy sedimentation. Lots and lots of details that go into this. So the one thing that I will leave you with on this particular slide is that there's a ton of resources out there when it comes to stream restoration. Get specific to what your goal for that project is, and then go and do your homework. I also don't want to oversimplify that the restoration process really takes time. In many cases, the planning, data collection, and the design phases of this can take years. Installation and maintenance seems like it could be an easy process, but depending on situation, the more urban you are, the more expensive it is. A few years ago, I did some research into this, and the numbers that basically come back is that restoring, doing restoration work along a stream in a rural or non-urban setting can actually be 7 times cheaper than doing it in an urban area. And there's a lot of reasons for that. Most of them are things that we as landscape architects encounter on many different projects. We'll talk about large equipment access, right? The ability to actually have the room and the land available to manipulate a stream channel as necessary versus having to control it with engineered structures. These are all part of this particular conversation. But in general, rule of thumb, the more urban the stream restoration project is, more than likely the more expensive and the more challenging when it comes to actually going ahead and creating a naturalized system when you're all said and done. It's just a simple matter of impervious surface. The greater the amount of impervious surface within the watershed draining to that stream, the faster that stream is going to flash during peak flow periods, the more armoring you're going to have to do. These are all factors when you think about the development of it. Before I leave this particular slide, though, the one thing I will say is that remember, the installation and maintenance could also be a years-long process. When you look at the guidelines that come out of the Department of Transportation, so DOT guidelines on this, often what they're looking at when it comes to doing stream restoration work in association with, offsetting or mitigating some road project work, you're often looking at somewhere in the neighborhood of 7 to 20 years of continuous long-term maintenance and intensive maintenance activities in order to actually see the stream restoration process all the way through. The upside for landscape architects is that this is an opportunity for us to be engaged in a long-term project. It's not a one and done. Restoration never is. This is something that we need to think about within our own practice. There's billable hours out there. There's good work that can be done. But the basics of stream restoration come down to this, is that streams that have become degraded often are degraded in a very similar manner. On the left, you see the before construction example with the overlay on top of it showing you this V-shaped notch cut into the ground. This is a very common pattern. It more or less basically says that the landscape surrounding it did not allow this stream to go ahead and move its course or change course during periods of high peak flow. And instead, what happens is that it continues to erode right through kind of the gravel base of the stream bed, right into the softer soils surrounding it. The stream gets wider, the stream gets deeper. This is a common occurrence over time. As you project forward into what's going on the right, the whole point of restoration is to solve that problem. How do you address the V channel, and how do you do it in a way that you can actually kind of manage this issue in the long term? This slide shows why it's so challenging to do stream restoration, because we're not actually talking about a static level of water. Obviously, flow changes over time, right? We have seasonal impacts, but realistically, we both have to design for normal conditions. We have to design for drought conditions, when water flows are very small, and we have to consider the impacts of flood conditions. And so, what volume of water do we end up designing for? And the answer is it depends largely on what's going on in the overall watershed. Unfortunately, the reality of that means that most stream restoration projects are relatively small and have little impact on the total volume of water that's coming into them, especially following large storm events. And so the question becomes, do we have to always design for the same peak flow as current conditions? And the answer is maybe that's not the worst case scenario. Maybe the worst case scenario is that we actually need to be designing this for larger storm events than what we've seen in the past, because that is the greater trend that we're seeing. It means that stream restoration is both more important and more challenging. And this particular slide just hits on 4 major points of flow design, or really starting to think about channel design and what it's going to take to bring all of this together. So top left, just look at this. The percentage of shade is equal to water temperature. Hot water is bad for a number of reasons. When we look to the right, we're going to see on the top that slow water is necessary. So you need pools, area where you're going to have sediment, dirt particles, things to have a place to go ahead and settle out naturally within the stream corridor. But on the bottom right, you're going to see we also need riffles and rapids, fast water areas that are going to scour out that sediment and send it on downstream so that we can expose some of the rocky substrate material. It's a necessary thing especially for fish. Bottom left corner, what you're going to see here is dissolved oxygen. Dissolved oxygen is an entire class in and of itself, but one of the things we can start thinking about here is how do we actually put some obstructions, some water changing levels, anything we can do to get that water moving, dropping, adding oxygen back into that environment. Think about it like a fish tank. You've got to do something to get the water moving and dropping to add oxygen back into the water. And on this slide, I'm really just going ahead and making a couple of points. One of those being that, site-specific design is absolutely a necessary part of stream restoration. You need practitioners who understand the site, that can work through these complex puzzles to come up with solutions that will actually work both for today and for the future conditions that we anticipate. The other thing is there are a few common elements, one of those being erosion control. This is both in process, but is part of the long-term goal. You're going to end up stripping a lot of vegetation away to do this correctly. So the grubbing, part of the process of going in and removing vegetation, the cut and the fill, in some cases can be very severe. This is along an active water body. How do you control that? And so you'll see in a lot of these examples is that tamping down erosion during construction, tamping down erosion in the long term, this is really what you're doing with stream restoration efforts. The other thing to keep in mind is big equipment access. I know I mentioned this on an earlier slide, but I can't overstate this. It takes large equipment and it takes skilled operators to make stream restoration work. You need to be able to access the streams. And again, this is what makes this a challenge. The next 6 or 7 slides, I'm just going to walk you through the overall basic restoration process. What you're seeing here on the top is what I would call kind of typical degraded stream conditions. You've got a very channelized stream that's been deeply cut into a V-notch. You certainly can kind of see that scouring underneath the bank is actually causing an area that you can see where the bank will actually start to collapse and further widen out the stream. Down at the bottom, what you're seeing is really kind of the restored stream condition that we're starting to look for. You're going to see that I went ahead and kind of left a dotted black line associated with the people, which are a scale element in these drawings. And really what that dotted black line is to show you is that sometimes the cut and fill can be, very severe to actually get down to a base that we can actually compact and protect in the long term, right? And so I'm going to walk you through some of the details on this, but this is the basic picture we're up against. It's degraded channelized streams, trying to put them into a more natural condition where we can actually get some meandering going on, allow the stream channel to kind of come up. The other thing of cutting down into these streams in this way is it allows you to actually store some of that peak flow across this broader floodplain area. This is often referred to as a two-stage ditch, if you want to think about it that way, that there's a primary kind of typical flow day channel that the water flows in, and then there's a larger, wider area that's actually receiving peak flow floodwaters. This slide happens to highlight the first two steps in the restoration process. Talk about grubbing. Grubbing is just another term for you're going to have to do a lot of clearing, right? And so this is one of those, if there are trees that need to be protected, that needs to be incorporated into grading plans. The cut and fill balancing on this, there's, certainly going in and removing a lot of material. So going in and doing a heavy cut, you're going to need a place nearby to actually drop that fill. This can be a real positive within this process. This is one of the great things about bringing landscape architects into this particular problem, is that this is our skill set. We should be very good at doing this. There's very few other professions that are trained at doing land sculpting in this way, and it's why I think more of us need to get engaged in this type of design. Here we're going to move on to kind of channel establishment and flow design. Again, I think really what this comes down to is that the design challenge you're up against is that anytime we have kind of the pipe or hallway approach to a stream, you're going to see that velocity, that uniform channel is going to allow it to get, speed up water flow, very few obstructions. It's going to continue to cut. You're going to get that classic V notch in the landscape, and the stream will go ahead and cut down and start undercutting the banks. The other thing, down at the bottom, as we start looking at this, what we're really aiming for from a flow design standpoint is that we want fast, slow, fast areas, right? We want some variety that goes along with this. The other thing that kind of the approach to design, it's more of a two-stage ditch, is that, I show them labeled out here in red as A, B, and C, is we want that channel, that primary channel, to meander through the space over time. We want to actually allow it to kind of take its natural course through a wider part of the landscape. By doing that, you're actually building in some fail-safes against kind of long-term failure of the design, right? You're allowing the channel to kind of move through the soils that it's naturally going to cut through. You're allowing it to kind of find its own pathway. We're also going to shape that, and we'll talk about some of the armoring we can do to shape that flow process in the next slide. This slide goes ahead and focuses in on kind of how do you prevent the same issues from kind of re-emerging post-design or post-restoration intervention. And so one of the things that you see in a lot of the literature on this is really understanding the undercutting of banks, how water is going to move and impact. So as we start to manipulate and meander the channel, what we're actually doing is that we are creating different conditions. Some of those places are intentionally going to be the spots where it will naturally want to undercut the bank. We're actually designing the failure point into the system. And the reason for that is that then that allows us to come in and do things. So amongst those different places, you're going to see down here on the bottom that what you're really going to get is that in yellow, you get this, I've got it circled here in yellow. It's a toe trench protection. What I'm really saying there is that anywhere where you expect the water to try and undercut the bank, that you've got kind of a bend that, you're going to speed up water right into that bank. What we can actually do is go ahead and dig down, and we can go ahead and armor or stabilize that toe trench. And so stone is often used in that setting. Riprap is something else that could be used there, but you're actually kind of anchoring down into it to provide something that's going to be able to absorb the energy coming from that water flow. But the other thing that pops up in this is that we've now exposed a wider floodplain, right? And so peak flow in a V-notch stream is somewhat nice because it just continues to kind of cut down into, and undercut the bank and just get wider on its own. But when it does flood in a restored stream condition, we're also going to have to think about where is that water going to, have a greater velocity, where those fast areas where you're going to get water flow, and we're going to have to go in and armor. And so I've kind of shown here in the example that you're going to have to actually go ahead and use some kind of, either mechanical or realistically riprap or some other material to go ahead and stabilize those areas that are most susceptible to erosion. This last slide really just focuses in on planting design, selecting the right plant material and placing it within the environment. One of the things that we see in the typical degraded stream conditions is a lot of times trees have been established, or the stream itself is undercut to the point where it's coming in contact with trees and their, large trees and their roots. And I think a lot of people have that sense that, that's the right thing to be doing, is try and get trees established. The trees will somehow miraculously, establish and mature and, stabilize the entire bank, and away we go. The problem with trees is that when they decide to fall down, when they get undercut, what happens is they actually take a large chunk of the bank with them as they go ahead and fall, and they can actually exacerbate that problem. Which is why a lot of in practice of restoration, stream restoration, what you're going to see is actually a move towards shrubs and willows, thickets, things that actually are going to send out a fibrous root system, but are not going to be extremely large, being part of the mix right in and around the streams. Willows are a great example. But willow thickets can get up to be 10 or 15 feet tall. They'll grow very dense right around the stream corridor itself. It may limit, the visibility of the stream corridor, but we can open it up in strategic places. This might be the right solution. The only other thing I will point out is that when we go ahead and design, so you're going to see here on the bottom left of the diagram, areas that are less prone to scouring. And again, this is that flood issue, is that we can actually identify some of those areas that are less prone to, to high waters that are moving quickly, and we can actually go in and establish a more diverse plant community in those areas, knowing that our investment is going to be safer there. And I think that that's an important part of the grading conversation as well. And I'd encourage you to go ahead and follow this video. This happens to be Green Lake, the Green Lake Association, a group that I've worked with in Wisconsin for a long time. They're very active in doing stream restoration work, and so this happens to be a really great time lapse to kind of show you the general process of what they're doing, especially kind of in that reshaping the landscape, regrading the landscape. And so it's a 3-minute video. I'd encourage you to just kind of duck out and go take a look at that. And again, there are many resources out there. These just happen to be a few that my daughter and I happened to come across as we were developing this material. Again, I want to give a shout out to Michaela. She did a great job helping me pull together some of the basic information on this and sending me off to develop this resource for all of you. I hope you enjoyed it.